Assalamu alaikum viewer. We are here to learn the limits and continuity in mathematica and their use. You people first subscribe this channel. This is the example. This is the problem. We want to solve this by using the limit x approaches to 9/2 and this one. Now in Mathematica we write this one, the limit, the L is capital, and the limit, the square brackets, put all of these value in this one, and then x, this x and the arrow is minus 5/3. Now this one is minus 5/3 is put here, maybe some mistake in this one, and the problem goes to minus 5/3 and we get the result 17/56. This is maybe another problem. This is not this one. Same like this one. This is the problem. Yeah, this one is put here. This is the in Mathematica we write this one and get the result. No, so limit is so simple in Mathematica, and there is its calculation. Here is another example, and this one. This one is the limit x approaches to 0, sin x over x. We want to calculate this limit. Now this is the limit. This one is this sin in bracket x, and this, and the result is the 1. When we compute this one, Mathematica represent infinity by infinity. You keep in your mind, Mathematica don't be represent this one. This represent infinity symbol to in English word infinity. This is the problem, that the limit 1 plus z over x whole power x, as x approaches to infinity we get this result. So limit is easy in Mathematica. Here we are discussing one side limit. The limit is this. This is the direction 1, and the limit minus 1, sorry, this one is the absolute of x over x, x approaches to 0, direction is minus 1. This one is the left hand limit, and this one is the right hand limit. Now that one is this one, limit 1 over x, x approaches to 0, direction is minus 1. Graph of that function are shown here. Here is another example. You people can watch this one. The limit x exponential is in bracket minus 1 over x, x approaches to 0, direction 1. That means the right limit. We are calculating right hand limit. And the second one is the limit x approaches to this, minus 1 is left hand limit, and their result is 0. We can plot all of these. This one is the definition of the limit continuity. In continuity, when the limit is exist and the left hand limit equal to right hand limit, then the limit of the function all are same, then the function is continue. It is so easy to know of continuity of a function. Let's suppose if we are talking about this one, is this function is continue? Yeah, it is continue. Why? It is continue when you draw a vertical line anywhere. There is the line don't be cut this line in two place, and there is no disconnection between the line. Same is this. In this figure, this one, this line and this line is totally, this function is discontinue, and if we draw a perpendicular line here, this line don't be cut each other. This one, this is the simple space, and this one also be discontinue.